This video is to provide an alternate to a whole house generator that provides most of the benefits at a small fraction of the cost. This is a project I did about a year ago, and this is described what I did. This is the generator I bought at Home Depot for a little bit more than $500. It's a 3-fuel, natural gas, gasoline, and propane. The end view. Note that it is rope start. Originally, I purchased a cover for the generator for mounting outside. The problem with that is you can't run the generator when it's raining outside. So I decided to build an enclosure. This is a CAD design which shows the enclosure. The design assumes that the unit is mounted on 2 4x4 pressure-treated lumber on the ground. The design also has no bottom, so all air comes in under the enclosure up through to the intake of the generator and also to the roof. This design CAD file doesn't show the roof exhaust, but you'll see that later on. This is a picture of the completed enclosure. You can see the tar paper roof, the vent on the roof to relieve the heat. You can see the gas line going in and the 2 access doors, and underneath you can see the line going out to the house. Here is a view with the control panel access door open. A couple of things to note: the on-off power switch, which needs to be turned on before you start the generator. You have a couple of 110 outlets that can be used for anything. We're not using any of them here because I have the RV outlet. The RV outlet is a plug-in that brings out 30 amps at 110 volts. So that's pretty much the limit of what you can get out of the generator for the whole house. This is the end view of the generator. You can see the air filter, which would not need to normally be replaced unless you were an extended run of the generator. It's a rope start. The rope pulls out from the side out through the access door. Also visible from here is the on-off for the gasoline, which is not normally needed here, and also the which can't be seen, but you reach in and you pull the choke. The choke is required for all the different fuels. The other thing in here is a little device that is replaced when you install it to convert it to natural gas. The top view of the generator. The entire roof is hinged for access to the top of the generator. The only thing you would need to open if you're using the generator is if you were using gasoline, because nothing else on top is required to run the generator. Natural gas tie-in. I already had a line running to the deck for a natural gas grill. The red valve was the existing valve. I put a splitter downstream of that valve and put 2 valves, one for the generator and one for the barbecue grill. The hose runs out from the valve to the natural gas tie-in on the generator. This is the generator ground connection. It consists of a copper rod pounded at least 4 feet into the ground, connected by a copper wire to the generator. Also seen in this picture is the part of the connection to the house, the cable to the house. This is a view of the theft-preventing cable for the generator looped around the frame of the generator. The stake is a spiral screw that screws into the ground 4 feet. It takes a tremendous amount of pressure to get that stake into the ground. So somebody would probably more likely have to cut the cable to get the generator. This is the outdoor RV receptacle box connected to the house. It runs a cable from the generator to this box with a leak-tight watertight connection. wire is running into the house, a 10 gauge 2 conductor for a 110 30 amp service. This is a Reliance power transfer panel. It's a 30 amp 220 volt panel. It was converted to 30 amp 120 volt panel because the generator I have only puts out 120 volt power. It was rewired internally for this, and also breakers A and B, which were connected to provide 240 volt power, is now disconnected, so it provides 220 amp 110 volt power. C, D, E, and F breakers are 15 amps, resulting in 2 20 amps and 4 15 amp 110 volt circuits. The unit is connected using the neutral and ground to the main panel. Power out to each load, it has been rerouted to this panel and then back through the breaker that it's been replacing with. So you see there's a switch there. The switch has 3 positions: line, off, and generator. So at no point was the generator hooked to the power of the house because there's a break in between. So that's the way this panel operates. This is a spreadsheet I set up to determine which circuits of the existing panel were going to be protected and backed up by the new generator. I have 4 15 amp breakers in the transfer panel and 2 20 amp breakers, and I need to match to existing 15 and 20 amp circuits. Sump pump hardly ever gets used, so that was out. The washer was not important. The furnace was the primary one, so that was a easy decision. The second one is the refrigerator and the kitchen and the oven. Well, the refrigerator is the most important one too. The other ones were more my decision. If you look at the lighting for the front and back bedrooms, it covers my computer. The family room, we got one TV that we can use. The lighting for the master bedroom, which includes my pickup for the 5G home internet, that was decided it was important. And then the final is the workshop outlet, which is a router and the Air TV in the basement, which allows the router to connect to the internet. So the 3 important things that are covered by the generator or the furnace, the refrigerator, some lighting, and everything needed to continue to run the TVs and internet. And since the internet is all of our TV is through the internet was required to run the TV. The markup of the transfer switch breaker assignments, so I know which ones to switch in what order. This is a close-up of the transfer switches and breakers in the transfer switch panel. A view of the breakers for the existing house. Note the existing house has 220 volt, 200 amp service. The breaker assignment list in the breaker panel. Note that there are 3 spares listed here. The 2XN on the bottom and in slots 39 and 41 are also spares no longer in service. This last slide is the cost breakdown of this project. Note that the generator was $536 and the transfer switch panel was $240. Those are the big ticket items. Every other item on the list is less than $60. It's just miscellaneous components necessary for the build. The total price for this project was $1,133. As I was finishing up this video, a strange event happened. The power went out. It's the first time in the 18 months since the system's been in service that I had to run the generator for providing power to the house. Kind of proves that the project paid for itself. Now, a couple of things I want to point out. My cost didn't include the cost of providing natural gas to outside because I already had it. You'd probably have another $150 in materials if you wanted to provide that natural gas, which makes it a lot better because you probably would never have to fill it, and the natural gas never runs out. The other thing is if you bought a bigger generator, let's say one that's twice the capacity and twice twice the cost, your cost would go up. But you would probably go with a 240 volt system, and you have a bigger panel, and everything would be sized for 240 volts. So it would still be substantially less than it would cost to put a whole house generator, which would be about $10,000. The one thing caveat with that is you'd probably have to go with the whole house generator if you wanted to uh, power your air conditioner. The air conditioner is the one thing in the house that really can't be provided with a portable generator. But other than that, unless it's an extremely huge one, other than that, this system will provide a lot of utility so that you can do the things you want to do, keep your house warm, keep your food cold. So that's the benefit of this project. Thank you.